Hi guys, welcome to this geometry video on congruent shortcuts. Today we're going to discuss the first congruent shortcut titled side, side, side. So we are learning that we can prove two triangles are congruent using a shortcut, and because this is way more time efficient to prove that they're congruent with a shortcut, and you'll know you're successful when you can construct a two-column proof to prove that two triangles are congruent using a shortcut, and today's shortcut is going to be SSS. So, do we always have to prove every part of a triangle is congruent to conclude they are congruent? No, we don't. So we just spent in the last lesson a ton of time proving that triangles are congruent and it was every single side, every single angle that we had to prove was congruent, because that was the definition of congruent. Well, it turns out we don't have to do that. We can only prove a limited amount, and because of the way congruence and triangles work, it guarantees all the rest of the things will fall in line and be congruent because of those things. So we are going to learn about congruent shortcuts. So two-column proofs, okay? A two-column proof consists of what things you can assume everyone understands and why, okay? So they're agreed upon statements. And that takes us to how do these assumptions lead to an answer? And the assumption is either right or wrong. So how does it apply to triangles? These triangles have three phases. First, you want to find that parts of a triangle are congruent. Okay, this leads to a congruent statement. And then the congruent statement can be made because of a congruence shortcut. So examples would be like you have sides, angles, and you have to detail why. And then that creates the statement of this triangle is congruent to this triangle because of one of these four congruent statements. And the one that we're going to focus on right now is side, side, side. So that's the one we're going to learn about today. So, reasons for parts being congruent, okay? We can immediately say that two parts of triangles are congruent because they're given. If this angle or side is shared, they're congruent. That's the reflexive property. And if something is the definition of midpoint or bisector, which we used in the last section a ton, we can definitely say that those two sides or angles are congruent. And vertical angles is another very, very common method for us to say, hey, we know that those angles are congruent. So, congruent shortcuts. There are four shortcuts, okay? The first one that we're going to do is we're going to talk about SSS. What we do need to understand for all congruent shortcuts is that the included side and angle refers to a side or an angle that is located between two consecutive angles and sides. So if you look at this one, okay, A is the included angle here. So you have side C and you have side B. Angle A is the included angle because it is between both of those sides. Side A is not included in any of these. So just understanding that angle A is included, but side A would not be included. So, side, 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 okay? If three sides of one triangle are congruent to three sides in another triangle, then the triangles are guaranteed to be congruent. So that is the first congruent statement, side, side, side. So we're going to do an example proof here, okay? Prove that triangle GIF is congruent to triangle GIH. Okay, so what I'm going to do, okay, I'm going to first start off with, I'm going to use the arrow here, all right? In my chart here, I'm going to use this as a, T-chart, okay? So as a T-chart, I'm going to say that these are my statements over here. These are my statements. And this is my reasoning. This is my whys. Okay? So the first thing that I can state is, according to what's marked, I can definitely say that side FG is congruent to side HG. So I'm going in the same order. So side FG is congruent to side HG. Okay? The reason for that is that it is given. This information is marked on the diagram. So I can say it is given information. The next thing that I can state, according to the diagram, is that F segment FI is congruent to segment HI. And again, that's marked information. It's given to me, okay? So that would be the reason that I put. Okay, so I have marked that two sides are congruent and given reasons for it. The last thing I can say is I can say that IG, side IG, is congruent to side IG. And that is the reflexive property. So let me give me a little bit to write out the word reflexive here. Reflexive. So reflexive property. So that means that I can make 1, 2, 3 congruent markings here. And with that, I have proven, okay, that this, and this pairs, all 3 pairs of sides are congruent. So now, according to, if I look back, remember back at my flow chart, okay, a couple slides back, I can look at this and say that the original request to prove that triangle GIF is congruent to triangle GIH. So usually when it tells you to prove something, when you finally accomplish the 3 things, okay, you know, I have side pair 1 here, I have side pair 2 here, and I have side pair 3 here. Because I have done this as 3 S's, okay, I can write S, S, S as the reason they are congruent. And that's it. That's my proof. It's 4 lines, okay? I have side 1 is congruent, sides 2 are congruent, and sides 3 are congruent. Therefore, by SSS, triangle GIF must be congruent to triangle GIH. That's it for SSS. See you in the next video.